Okay, question number 8. For the hydrogen atom, the energy level En is given by this equation. Now, this equation only for hydrogen atom, so means it cannot be used for other atom. Okay, it's only for hydrogen. Now, where n is an integer and known as a principal quantum number. Okay, so calculate the energy level of the ground state and the energy level of the first excited state where n equal to 2. B. Determine the wavelength of radiations emitted when an electron makes a transition from the first excited state to the ground state. In which region of the electromagnetic spectrum would you find a spectral line of this wavelength? So in which region, part C, the electromagnetic spectrum would you find in the spectral line corresponding to an electron transition between energy levels from quantum 6 to 7? Justify your answer. Okay, let's solve part A first. Part A say that they have transition from n equal to 1 to the first excited state n equal to 2. So when n equal to 1, E1 equal to negative 2.18 times 10 power negative 18 joules. Okay, so when n equal to 2, E2 will be equal to negative 5.45 times 10 to power negative 19 joules. Okay, so this is part A. Now part B. Part B say that determine the wavelength of the radiation emitted when electron make from first excited state to the ground state. So it means that I excite the electron, go to the excited state, then suddenly it dropped back. So it means that it lost an energy. Okay, it lost an energy, so it means that the energy must convert into some form. So this convert into the waveform. Okay, so means that delta E will be equal to hc over lambda. So where lambda is what I have to find. So lambda equal to hc over delta E. So your h is the Planck constant, and c is the speed of light. Okay, so divided by the change. Okay, so now the change of energy, I will choose that as a modulus. Okay, because what I need to know is only the wavelength that is being transferred. Okay, so negative 18. Okay, sorry, 19. This is 19 being converted. Okay, so that my lambda here, it should be 1.22. Oops, sorry, it's 1.22 times 10 to the power negative 7 meter. Okay, now for part C, in which region? So if I want to find in which region where the electromagnetic from 6 to 7, so justify your answer. Okay, so means that I have to calculate. Okay, so first thing that we calculate is the, okay, I will use another page. So delta E here from 6 to 7 is 2.18 times 10 to the power negative 18. So it's 1 over 6 square minus 1 over 7 square. So what I get is 1.607 times 10 to the power negative 20 joules. Okay, so lambda will be equal to hc over delta E as part B. So what I get is 1.24 times 10 to the power negative 5 meter. So this is the infrared region. Okay, region.